questions? Okay. Live. Let's see, we last left off with your watching videos. Wrong section. So I'm going to do a quick run through of the stuff that's in the videos. If you have questions, please ask. All right, so when I'm dealing with chapter 2, there's some vocab words that we have to be familiar with. These are all vector quantities: position, displacement, velocity, acceleration. And the symbol for position.
Where it's at.
Pardon?
Symbol for position X.
Yeah, that's the one I typically use. Any others?
Or S.
I got R. What did you say?
S.
S? Yep.
Yep.
And I think somebody just said it. And rounding it out. Those are typically the ones I tend to stick with X, but sometimes I'll just flip to R because I just felt like it. Displacement. What symbol do we use for displacement? Yeah, just throw a delta in front of it. So delta X, delta in front of whatever we're using for position, because displacement is change in position amongst a different definition. Velocity.
V.
Like that.
With a.
Thank you very much. If it doesn't have the vector symbol over it, what is it? What does it represent?
Acceleration.
Nope.
Oh, is it speed? Is it speed?
Yes, it is. So we have some speed over here. What about displacement? If I don't have the vector symbol over it, what is it? I guess we'll come back to that. All right, symbol for acceleration. Somebody can take a wild guess on this one. Yep, and then I heard the last little bit with the vector symbol. If I don't have the vector symbol over it, what is it called?
Acceleration.
Yeah, that's unfortunate, but yeah. The early tests, if you're looking at old tests, I might not put, at this point, typically after I say acceleration, if it's not obvious from the context, I'll put A vector or A without the vector so you know which one I'm looking for. If some of the early tests, I might not have done that. I think I'm pretty decent about it now on all the current tests and master sets and so forth. But if you have a question about which one I wanted, you can't pick it up from context, just ask. All right, so back to displacement. If I just looking at delta X, well, one, if it's a vector, what do vectors have? different from those things over there.
No direction.
Okay. You identified the difference, let's make sure you're clear.
Sorry.
Direction, which one has directions?
Vector.
Vector, okay. They have a direction, they have no direction.
Right.
So if I'm talking about, I start here, I end up at home, and I'm not cared about direction, how would you,
It's distant.
yeah, there we go. Somebody can read my mind. The rest of you, work on it. Let's stay away from the dark areas. Okay. So I mentioned displacement is the change in position. If you have this delta here, that means change. So this can be defined as change in position. Or, what's the other definition for displacement? All right, what's position? We'll jump, right? What is position?
Where a man. X.
No, I'm looking for a definition.
Oh, where a man. Yeah. Where a man. Where you are from the origin.
There we go. Now, where am I? I'm right here. I need some sort of reference. So for position, it's where an object is with respect to the origin, or on a number line 0, and then displacement.
Where you're at relative to your starting point.
Yeah, and that's the other one here. With respect to the starting point. Velocity? What is velocity?
The speed that you're going.
Say it again?
The speed that you're going.
Then that would be speed.
I know.
You lost half of it.
And the direction?
Yeah, there we go. Yeah, don't forget, this is velocity. When you hear velocity, that is a vector. Actually, when you don't hear it, it's still a vector. But velocity is a vector, so it has a direction. So how fast an object is moving. And in what direction. The police will pull you over because of speed. They will not pull you over because of velocity. That's why it's a speeding ticket, not a velocity ticket. Velocity. Anyway. And acceleration, vector.
The change of velocity.
You said change in velocity?
Yeah.
You're close. You see the ballpark. You're almost entering. Maybe you've taken one step in.
Change in velocity related to time?
Yeah, with respect to time.
Yeah.
The reason why is, I'm cruising along at 60 miles per hour east. I then go to 40 miles per hour east. My change in velocity was negative 20 miles per hour east, but that doesn't tell at the rate at which I was slowing down. Acceleration deals with the rate at which the velocity changes, whether it's slowing down or the other ways velocity can change. All right, so acceleration, so time rate of change. Of velocity, actually, let's just use the shorthand notation. Now, this last bit, we can express this slightly better than that because time rate of change is velocity, not particularly useful. So, of course, we will use math, which Time Life Books claimed was the purest distillation of knowledge. It's the language that we're going to use. And so this math form, we would write acceleration is the change in velocity over the change in time. Likewise, velocity, how fast an object is moving in what direction, it's sort of vague. It's also the time rate of change of position. So we can also write, we got that one, and then time rate of change of position, which translate into velocity is the change in position over the change in time, or displacement over change in time. And with time, you can also get away with just displacement over time, although officially it's really change in time. So let's talk about that bit. Here's the thinking. Change in time is the final time minus the initial time. Change is always the final whatever minus the initial whatever. The initial time has some flexibility. The initial time is basically when I start the stopwatch in a lab, or when it passes the photo gate in the lab. On our calendar, time started, I guess, January 1st, or however many years ago. Time starts at some point in order for us to give us a reference. So in physics, we can set the initial time basically to whatever we want. So if I set the initial time to 0, then the change in time is equal to the final time, which is just the time. So sometimes we get a little sloppy in our notation if we just say the displacement divided by time is velocity. Really, it's the time through which that position changed. There are also other shortcuts with displacement. We have displacement is, again, it's a change, so it's final position minus initial position. The initial position is, we could make whatever we want. We basically set up a reference frame. So we can make that 0, in which case, suddenly, if that's 0, then position and displacement are interchangeable. Some textbooks are much more picky about that than others. I will say that I tend to be picky about that. Questions up to here? All right, let's get into the plus minus 0. These are also part of the videos. We're just dealing with the vector piece of it, so let's just get rid of the scalar pieces over here. When is the position positive?
Anything to the right of 0?
Ooh, make it more general.
Anything to the right of the origin?
Ooh.
No.
The origin or 0 is not the part where I'm equivalent. The math people got you, didn't they? Put you into a dark room, brainwashed you, flashed the lights, good cop, bad cop. What's wrong with what he said? Yeah. Wesley made an assumption that I was not willing to make. What's wrong with that? What assumption is made if
You're assuming it's positive.
what's positive?
Being to the right of 0.
Yes, that's the assumption Wesley made. It is not always convenient to do that. I mean, you could always go with the math people, positive, positive, positive. But sometimes that is making the problem 4 times harder than it needs to be. Choosing the right coordinate system actually becomes, as the farther you get in physics, becomes even more and more critical. So, if we generalize what Wesley had said, take into account what Dominic said, when is position positive? And this might be a case of something so obvious that you,
When it goes away from the origin,
ooh, don't,
It's not negative.
where you decide it's positive.
Say that again?
Where you decide it's positive.
At this point, I will take that, and you're almost right. It's when you're on the positive side of the origin. It's as simple as that. Now, is the positive side to the right? No. It depends upon the problem and who's doing the problem. So, it is positive if on positive side of origin, or 0, or whatever you're using as your reference. Not negative, it could be 0, and 0 is not positive. Or is it? That's a philosophical thing. All right. When I was taking pre-calculus, we did a proof to show that negative 0 equals positive 0. And then when I took the PSAT, there was a question where it depended, is positive 0 the same number as negative 0, or do they just have equal values? And I missed it because I assumed that they were two different numbers that just happened to be equal to each other in terms of value. So anyway, I digress. So displacement, when is displacement positive?
Anything on the more positive side of the starting point?
Yeah, I'm not quite sure you don't need the word more in there when you're on the positive side. All right, I do need to differentiate one thing here, displacement. There's instantaneous displacement, and then there's overall displacement. That is true over there for overall displacement. And if I just say displacement, the default, overall. So there's overall, this is the default, and then they're instantaneous. So if I consider that to be my starting point, and that's the positive side, my instantaneous displacement, in other words, where am I relative to where I just was, is positive. My overall displacement is positive. But as I go this way, my instantaneous displacement is negative, because where am I relative to where I just was, right there. But my overall displacement is positive, because I'm on the plus side of the origin. So this applies for overall displacement, which is the default. If I want you to deal with instantaneous displacement, which I do there's one lab exercise where I specify it, I need to use the word instantaneous. All right, velocity. There is average velocity and instantaneous velocity. Instantaneous is the default, and same with acceleration. There's the instantaneous, and then there's the average. Instantaneous is default for acceleration. So when I say when is the velocity positive, I'm talking about this one. So, when is velocity positive?
When it's on the positive side.
When what's on the positive side?
The movement?
Is on the positive side?
The object.
No, that would be a positive, either displacement or position. Dominic?
The directions going in the positive side?
If you're moving in the positive direction, you have positive velocity. When you move in the negative direction, you have negative velocity. Now there I was, picking on Wesley for saying to the right was positive, and yet I'm just reinforcing that. So, should make the other way just to, then I'll get confused. I get brainwashed by the math people too, but I'm so used to that being the positive direction from your point of view. All right, so if moving in positive direction and acceleration, this is where most people have issues. When is acceleration positive?
If the velocity is positive?
Nope. Said time? Well, time's involved. I am making the assumption that we are not going backwards in time.
If you're accelerating, not decelerating, if you're like going up in speed?
All right, let's drop back for just a second here. Deceleration is not a physics term.
Okay.
That's a everyday outside world,
Okay.
which does add to confusion. Because the word acceleration, if I'm accelerating in my car,
Mm-hmm.
most people think I'm speeding up.
Right.
However, acceleration deals with the change in velocity. So if you're driving, what are the 3 accelerators you have easy access to? Assume automatic transmission. Say it again.
Gas and brake,
There's 2 of them. There's one more.
reverse,
Uh,
turning,
Well, it's got a wheel.
yeah, steering wheel. Not reverse. Because if I hit the gas pedal, I'm going to speed up, my speed changes, therefore the velocity changes. If I hit the brake, I'm going to slow down, my speed changes, therefore velocity changes. If I change directions, the steering wheel, if I change directions, my velocity changes, because velocity deals with the direction also. If my direction changes, my velocity changes, there is acceleration. All right, back to my other question. Matter of fact, Giovanni didn't even hear the question, but he's gonna answer it right now. He's gonna just blow my mind away. Go.
You got it.
Speed equals distance over time.
One of these days it's gonna work. So when is acceleration positive?
When the velocity is positive.
Not when velocity is positive. You see the ballpark from a distance. But you missed a very critical